Hi, welcome to Heimer USA. My name is Brent Holton. I'm the president of Heimer North America, and it's a pleasure to have you here today. You've just stepped into our 30,000 square foot facility located in Villa Park, Illinois, which is just outside of Chicago. Again, we welcome you here. This is the main headquarters for Heimer North America. As you all know, our product is all made in Germany at Heimer headquarters. But here we sell, service, and support the product locally for the North American market. We also have a facility in Querétaro, Mexico, where we do the same. This part of the building, this 10,000 square feet of the 30,000 square feet, is what we call the Heimer Competency Center. This is an area where we have all of our equipment set up under power, always ready to show you. So you're always welcome to come visit us and see what we have. We always have the latest and greatest, and it's all under power and operational. So again, thank you for coming today, and let's show you around. So this is the Heimer Power Clamp Comfort i4.0 series machine. It's our brand new shrink fit machine. We call it i4.0 because basically we have a very unique control here. It's a full-blown computer incorporated with the machine that allows you a lot of connectivity options as this whole industry i4.0 thing grows, where you can actually connect with bailiff chips, you can scan tools, you can end up setting lengths, get some extra data here. But as a start, what we do is we basically scan the tool holder. So we have a scanner here. We scan a data matrix code that's on the tool holder. It tells us exactly where to position the coil. In this case, it tells us to bring it to position 4 for this diameter. We bring the coil down, very easy squeeze of the handle. What I'm going to do is press and hold this button. Within about 5 seconds, the tool will release. I'll be able to remove it and bring in my new tool. So basically now the tool is heating up. I take out my old cutting tool. If I have time, I grab my new cutting tool, put it in. So here I've effectively changed the tool within 5 seconds. And that tool change was extremely accurate. It was very consistent. So that's a big advantage of shrink fit, is the consistency of the setup and the process. What I've done here now is I rotated this turntable to put the hottest tool furthest away from me, and I'm actually grabbing a cooling body. So the cooling body has circulated cold water going through these aluminum cooling bodies, and I put it over the nose of the tool, and that draws the heat out. Now there's no water touching the tool. We don't believe in shocking the tool with a drenching of water. Instead, it's going through some channels through the aluminum bodies that will draw the heat out within about 30 seconds to a minute. You'll see that there's a light on that's red. That's indicating the tool's still hot. It will start to blink when we can touch it. But in the meantime, we don't need to waste our time. We can go straight to the next tool. I've scanned the tool. It tells me to position it to position number 7. I bring it to position 7, bring the coil down, press and hold the button. Now you'll notice this is a unique tool too. This is actually a steel into steel situation, which some people didn't think was possible, but it is with the Heimer inductive shrinking technology. I take out the extension. If I want to put a new tool or extension in, I put it in. Effectively, I've changed that tool very fast. Now, I bring it over, grab my larger cooling body, put it on the tool. Meanwhile, this one is blinking, that first tool, so that first tool that I already shrunk is already cool. So I can take out the cooling body, put it back, and here I go. Now the tool's completely cool. I can put it on my cart, grab my next tool, get ready to go. In the meantime, I have that third tool ready to go. So the other thing that's nice about shrinking in general is just the benefits that it offers you. So you get the great run-out accuracy, great gripping torque, you have 360-degree clamping, fantastic balance repeatability because there's no moving parts like nuts, collets, discs, bearings, things like that. They're going to have a huge influence on the unbalance of a tool holder assembly. Shrink fit doesn't have that. You've got the extension capabilities, you've got slim profile capabilities, you've got coolant through capabilities, like coolant around the tool, coolant through the tool, depending on your needs. So it's really a complete offering. Now what's best though about it is the consistency of the setup. Everyone in the shop sets the tool the same, whether they've been there for 20 years or 2 weeks. It's the most consistent method of tool clamping in the industry. The other thing though is, this is fancy. It's nice to see how the shrink machine works. You're seeing how easy it is to work. But really, we wouldn't even be talking about it if you didn't get the benefit of what you get out of the tool holder itself. And what that gives you is the ability to really run your machine to the max. You've got the ability to keep very tight tolerances, great surface finishes, and of course you can machine your parts faster. And that's where the real money is made, by machining your parts faster. So while this is an incredibly simple, easy, effective method of clamping a tool, we wouldn't even be talking about it if it wasn't for the benefits you get by using such tools as this. So this is our Heimer Tool Dynamic Comfort Balancing Machine. So as mentioned before, Heimer is the only tool holder builder in the world that makes a balancing machine. We've become the worldwide standard for balancing tool holders and grinding wheels. How it works is very simple. So we take our tool holder, so now we've assembled it as it will actually run in the machine. Yes, this tool holder is balanced at G2.5 at 25,000 RPM. It's a shrink fit chuck with the best balance repeatability in the market. But we've introduced a cutting tool. So now we added the full assembly as it will run the machine tool. We clamp the tool in the machine, the balancing machine itself. It's clamped as it would be held in the machine tool spindle. In this case it's HSK, it's grabbing and drawing the tool in with face contact. If it was CAT 40, BT 30, it would actually be grabbing on the pull stud and grabbing the tool holder into the machine itself. We shut the hood. The operation is extremely simple. Press the green button. This will start the rotation to actually start the measurement of the tool. This tool is trying to be balanced at G2.5, which is a quality grade dictating permissible imbalance at 20,000 RPM. The tool finishes the first rotation. We index the tool holder 180 degrees in the spindle, and that's to take the unbalance of this spindle out of the equation. So now we're truly just getting the unbalance of the tool holder assembly as it will run in the machine tool spindle. We take one more reading, and then we're going to get our results. So now the machine stops. We look over to our computer screen, and you'll see that, it's red. We are not balanced to G2.5 at 20,000 RPM as we requested or wanted to be. Instead, we're balanced to G2.5 at 1,756 RPM. At the 20,000 RPM, we're currently at G28.4, which is way out of spec per what we want to be running here. So what do we do? Well, again, the machine told us that we're heavy at this location. Now we do have an option of actually drilling to remove material or milling to remove material, or we have rings where we can displace material. In this little demo we're going to show you today, we're going to actually add weight via our shrink fit holders that have these drilled and tapped holes. So the screen itself gives me two indications of where to add weight. In a perfect world, we'd add weight exactly 180 degrees opposite of where we're heavy, but you don't always have a hole there. So it's going to give me two spots to add weight. In this case, it's telling me at angle 180 to add a weight of 0.78 grams. So we have a little tackle box here full of weighted screws. The weighted screws have different colors, they have different lengths. And we look and we say, okay, 0.78, what do I have? Well, I've got a screw that's 0.77, that's close enough. We grab that screw out of the box, put the box down, and add the screw to the holder. We have a little screwdriver here, line it up, and add the screw to the holder. Now we bottom these screws out. After you've bottomed the one screw out, we look onto our computer screen. It tells me, okay, there's another angle to add weight. It's at angle 270, which lines up with the spindle face. It tells me to add a weight of 1.05 grams. So again, we look in our tackle box. Here, there's 1.06. Very close enough. So then we grab that weight, that screw, and we're going to add that to the holder. Again, just lining up the screw into the thread of the holder and bottoming it out. After we bottom it out, we're going to check this to make sure that I did this correctly. So basically, after bottoming it out, we shut the hood, start the process again. So again, it's going to ramp up to the 1100 RPM. At that point, it will take a reading, and then we'll index the tool 180 degrees. Why are we doing this? Because really, in order to get the max out of your machine tool, you want to make sure that your tool holder assembly is balanced. And I use the word assembly because that's important. Yes, the tool holder is pre-balanced, but you want to look as it will actually run in the machine. If you have vibration, if you have problems, the operators are going to slow down the feeds and speeds, and the parts will get done slower. Also, if it's a supercritical finish application, like in a die mold application, let's say, you'll actually have quality issues that relates to the part tolerances and surface finishes. So now we have virtually zero unbalance. We're actually at we're at G0.9 at 20,000 RPM. So you see the process of balancing a tool is very, very simple, but it's very important and often overlooked and should be considered, especially if you're looking at the Industry I4.0 concept of lights out machining and consistency in the shop. Then balancing becomes extremely important. So as you see with this example, most people say, shrink fit holder, I don't need to balance. In this case, this holder When the cutting tool was introduced, it was way out of balance. Now we've balanced it within a matter of minutes, and we're ready to go. So now we're going to talk about the Hymer microset machines. These are our tool presetters that really helps complete the full tool room that Hymer can offer. So with these machines, it allows you to set your Z-axis, check your dimensions, both in X, check the radiuses, you can check run out of a tool. It's a very handy tool to really make sure that you have the exact data of the tool assembly that you're putting in the machine tool prior to it going to the machine. So first we'd like to talk about our Uno Premium Series machines. It's one of our entry-level machines, but it's a very solid machine. It's got cast iron both on the X and the Z axes. It's got some clever features that make it very handy and easy to use. One, we've got this, what's called Release by Touch. This allows the machine to move in X and Z without any pushing of a button. So if I release here now and I push here, the machine doesn't move. But as soon as I put my hand on this, it makes it easy to move. So you're not having to push a button in order to move the carrier around. So now another nice feature, we have this red laser that actually helps you find the edge of a cutting tool very easily. There's no guesswork, so that's another nice function. What we have set up here is we've got our 50 taper ISO master spindle with a reduction sleeve in there holding an HSK 63A tool that we've actually clamped the tool, and now we can start measuring the tool. So again, the construction is rock solid from Hymer with the cast iron construction both on the X and Z. And then we've got some very handy features with this simple to use, release by touch, and also the laser edge finder. So now we're going to show you a quick demonstration of the Uno Premium machine. So this Uno Premium is one of our entry-level presetters here, but it's got a lot of capabilities. Very easy to use. So again, we've kind of gone over the construction, but now I'll just show you how we bring it in. So again, using our little laser edge finder, this is a 4-flute end mill. We're going to come up here, and we just find the edge very easily with that laser, bring us into position. So now what we're going to do is we're going to pick up 4 cutting edges. So we apply the first edge, because you notice it's green. Now we look to find our second edge of our 4-flute end mill. It's green, so we apply. Now we hit the third cutting edge, and then we apply. And then finally the fourth cutting edge. So now we basically have measured all 4 cutting edges. We're going to take a quick look at a graph that shows us that we're in tolerance. So both the X and the Z dimensions turned out to be in tolerance. Along those lines, we can also print out a label. So we're going to give the tool a tool number based on the pocket of where this is going to ultimately be inserted. And now we're going to get ready to print it out. And we have the label. So the label has the Z and the X dimension. It also has a QR code, so we can actually scan, keep this with the tool, the cutting tool, and we can scan it to keep track of where everything is in the process. So now we can turn a spotlight on. This actually allows us to look at the cutting edge. So it's hard to see maybe on this video, but you're actually seeing a pretty damaged cutting edge in this case. So this would be a clear indication that, I probably shouldn't even use this tool. It'd be a waste of time because it's already been used and it's damaged. So again, this is our Uno machine. It's the premium. It's the manual version. We also offer the same machine in what we call the autofocus, which basically means the C-axis, or this axis, will rotate. We also have it available as the auto drive, where the C-axis rotates, but also the Z and the X move automatically. So it's a true CNC presetter with the same profile, same capabilities. And with Hymer, we're always trying to give you the best and most consistent tool holder assembly possible so that you can really get the max out of your machine tool. So that is really the takeaway that I'd like to stress here today, that really where we can be beneficial for you, besides some of the obvious things of deep reach, slim profiles, great surface finish, is just giving you the best foot forward. And as we move into this Industry I 4.0 movement where data is collected and analyzed by the machine, this will be even more evident to have a full tooling solution. And that's something Hymer can offer. So again, thank you very much. Hope you're all doing well, and wish you the best. Thank you for your time.